My name is John at Whalen Speed, and I'm going to talk about why it is important to check bearing clearance. We have a engine blueprint sheet that we fill out all the most important things to do with an engine that you get with your engine package. We actually saw some variance between bearing manufacturers on this Evo 10 assembly we're putting together. Both bearings are just a standard H bearing, a race bearing. And we noticed the ACLs were a little loose, so we tested a Clevite bearing that we had here, and this one made more sense as to what we would expect to see for a rod bearing clearance. So I'm just going to go through what it takes to like truly check this and get like a very accurate number. I already set our mic to the rod journal. This is a brand new crankshaft. We balanced it, and I repolished it after I've checked this, because sometimes you can put a little scuff on the surface. So I'm not going to do that for you right now. I've already set this, but I do have to set my dial bore gauge to my mic. So I'm going to do that now. So I already got it set up for the right size. And you can see here, it does have some preload. So you're going to want the maximum number while moving this. So I know it's going to be around 4, so I'm going to move this over there now. Now I hold if you do get one of these, I hold it with my fingers to try to center it as much as possible so you can easily do this. So, as you can see, we are extremely close to 0. Alright, so my bore gauge is set to the crank journal now. It is zeroed out on 20 thou, 0.02. So you just kind of want to make sure that you, I guess, keep an eye on that just in case something's crazy off, but generally it's not if you're, starting with new stuff. So this is zeroed. And now we're going to check it against the ACLs first. So I'm not going to tell you exactly what we run, but I'll give you a rule of thumb that generally an inch of rod journal, or inch of any journal, you're going to want 1 thou bearing clearance. I mean, that's pretty general. You can do your own research. I'm not going to tell you what it is, but so you can see the ACL here. And then when you do this, you kind of want to be careful because you can scratch it. So you want to pull it in to the bearing and then bring it down to the size. So this one here, I also want to make a note that the bearing is not perfectly round when it is in this journal. So like if you're plastic gauging or whatever you're doing, you need to make sure that you are 90 degrees the parting line. Your bearing's smallest clearance is going to be here, and it opens up as it runs around. So it's like kind of egg-shaped, and I could show you that here. So when you do this, you're going to kind of want to bounce around and see. So I got 2.6, so that's 2.6 thousandths, so 0.0026. But as I move this, you can see it starting to open up. So we're almost to parting line. It's almost a 4 thou. So let's check that one more time. So it's 2.6, and then let's check our Clevite. So our Clevite, this is standard bearings, mind you. So these should be like almost identical. And the Clevite bearing is showing 1.8 and a half-ish. Let's see here, let's rotate. 1.7. 1.6 I've seen. So you can see it moving. All right, so if you want to change the clearance, you have options. I get asked a lot, how do I change the clearance from what it is? So they luckily make us some different bearing options. So H is going to be standard size. If you want extra clearance, you can run an HX. That'll give you 1 thou extra clearance. If you need a smaller clearance, you could run a .025. Generally, you do not need to run a smaller clearance unless there's a problem. So everybody pretty much runs a similar nomenclature for the style bearing. You can go on Clevite's website. They actually give you a nice little part number identification. So H is a high performance bearing. You can read about high performance bearings on their website, but they're kind of designed to handle the loads that we put these things through. The X at the end signifies 1 extra thou clearance, and then there's some other ones that generally kind of suit the domestic market. But so say you don't need 1 thou extra clearance, you only want a 1/2 thou extra clearance. You can mix bearing shells, so you can run 1 X bearing shell and 1 H bearing shell only. That'll get you a 1/2 thou. If you are measuring and you get like a large number, so say you have all standard bearings, a brand new crank, your crankshaft journal size is right, and you check your rod and it's big, I would instantly assume that the shaft tunnel size, your housing bore size, is too big, and that's a problem. So on ACL's website, I just pulled this from, they give you information. So you have your tunnel size here for your rod bearing. So you have a minimum and a maximum. It's a very tight clearance, so you only have 3/10. If the number is bigger than this max size, your bearing clearance is going to go up at a much higher rate, I guess. So you can't, I've seen like some builders, they'll measure the thickness of the bearing shell, and then they'll multiply that by 2, and then they'll subtract that to get like a bearing clearance just from calculation, and that's not the correct way to do it. So when you put this in a tunnel and you torque it down, the bearing will crush and the size will change. So you must do it this way to do it properly. If you do not get enough crush, the bearing will spin. So if you have a big clearance and you are just going to run with it, I would expect you to spin a bearing rather quick. So we've got them from manufacturers that have been switching equipment, or there's a new guy running or whatever, that the tunnel size was big, and to fix that, it's kind of a pain. You have to recondition the rod, or really just contact the manufacturer, send it back, and get it fixed. But the tangs don't actually hold the bearing in. The crush of the bearing is holding the bearing in its place. Aluminum rods, obviously, they'll have a dowel to hold them from severely rotating, but in an aluminum rod state, they still rely on crush a lot. So that really concludes what we're talking about here. How important it is to have a very tight window for bearing clearance and staying consistent with that number to have a very reliable engine.